ዛሬ ስለ ኤሌክትሮማግኔቲክ ራዲዬሽን ነው የምንማረው። ይህ ቶፒክ ኬሚስትሪ ቴክስት ቡክ ግሬድ 11 ቻፕተር 1 ላይ ይገኛል። ኤሌክትሮማግኔቲክ ራዲዬሽን ይላል። under this topic and activity አለች። እቺም ብትሰሩ አሪፍ ነው። activity 1.10 form a group and discuss the following questions, then present your response to the whole class. Explain how energy travels in space. Question number 1, what is the importance of electromagnetic radiation in chemistry? Question number 2, what are the common features of different energy sources? ጥያቄ ስሩት። ግን እንዲሰራላችሁ ከፈለጋችሁ ደግሞ ኮሜንት ስር ጻፉልኝ፣ አብረን መስራት እንችላለን። ሶ ይህንን ካልኩ ቀጥታ ወደ ቶፒኩ እንሄዳለን። under electromagnetic radiation we'll see some main points. መጀመሪያ ላይ የምናየው ስለ ማክስዌል ቲዮሪ እናያለን። ስለ ማክስዌል ቲዮሪ ካየን በኋላ definition of electromagnetic radiation እናያለን። definition of electromagnetic radiation ካየን በኋላ ደግሞ the primary characteristics of electromagnetic waves እናያለን። እሱን ካየን በኋላ ደግሞ electromagnetic spectrum እናያለን። electromagnetic spectrum ካየን በኋላ ደግሞ final ላይ some examples which are related with calculation እናያለን ማለት ነው under electromagnetic radiation. According to Maxwell theory, light contains electromagnetic wave, and electromagnetic wave contains electric field component and magnetic field component, which means light contains electromagnetic field component and electric field component and magnetic field component. These two electric field and the magnetic field components vibrate in two mutually perpendicular planes. For example, this is an XYZ plane. Down magnetic field component not, ichኛው ደግሞ electric field component not. So these two magnetic field component and electric field component vibrate into mutually perpendicular planes. This is the core point or the main principle of Maxwell theory. Next, we will see definition of electromagnetic radiation. Electromagnetic radiation is emission and transmission of energy in the form of electromagnetic waves, which means energy መልቀቅ የሚችል as well as ማስተላለፍ የሚችል የኤነርጂ ደግሞ it must be in the form of electromagnetic wave, which means it must be the one which contains both electric field component and magnetic field component. This is the definition of electromagnetic radiation. So እቺን ፓራግራፍ በደንብ ካየን ማክስዌል ቲዮሪውን main principle as well as definition of electromagnetic radiation በደንብ ኮንሰፕቱን እንይዛለን ማለት ነው። Next, properties of electromagnetic wave or the main characteristics of electromagnetic wave ነው የምናየው። መጀመሪያ ላይ wavelengths, second frequency and the third one speed. እነዚህ ሶስቱን እናያለን። Wavelength is represented by this symbol. This is a Greek symbol which we call it lambda. Lambda ነው የምንለው። So wavelength is the distance which the wave travels during one cycle, or we can say it's the distance between two consecutive crests and two consecutive trough ማለት እንችላለን። The unit of this wavelength is meter. But when we deal with short wavelengths. But when we deal with short wavelengths, we can use nanometer as a unit of wavelengths. We can use picometer as a unit of wavelengths. We can use angstrom as a unit of wavelengths. This is the main principle behind wavelengths. Second, frequency. Frequency is represented by V, or we can say nu. በግሪክ ኑ ብለን እንጠራለን። This frequency is the number of cycles the wave undergoes per second. This is the definition of frequency. This frequency is expressed by 1/second, or the unit of frequency is 1/second, or we can say second inverse. This second inverse is equivalent with hertz. It's equivalent with hertz. The third one is the third character of electromagnetic wave is speed. The speed of electromagnetic wave is depend on two things. Number one, depend on the type of the wave, and depend on the nature of the medium through which the wave is traveling, which means the speed of electromagnetic wave which travel in air is completely different from the speed of the electromagnetic wave which travel in water, and it is completely different from the speed of the electromagnetic wave which travels in the vacuum. That is why the speed of the electromagnetic wave is depend on two things. Those two things are type of the wave and the nature of the medium through which the wave is traveling. ሁላችን እችን ፎርሙላ እናውቃለን። Speed of light is equivalent with frequency times lambda. When our electromagnetic wave is traveling in vacuum, the speed of light is equivalent with the speed of the electromagnetic wave. But vacuum ውጪ ከሆነ ደግሞ ሁለቱን ነገሮችን ኮንሲደር እናደርጋለን ማለት ነው። Unless if our electromagnetic wave travels in vacuum, speed of light 3 times 10 the power of 8 meter per second እንጠቀማለን ማለት ነው። as ሁላችንም እንደምናውቀው 3 times 10 the power of 8 meter per second speed of light, speed of light እና speed of electromagnetic wave equal ይሆናል ማለት ነው። The third one is electromagnetic spectrum ነው የምናየው። Electromagnetic spectrum is the spectrum which arranges electromagnetic radiation from the lowest wavelengths to the highest wavelengths. ይሄ ማለት ምን ማለት ነው? The wavelengths of gamma rays less than that of the wavelengths of X-rays, and the wavelengths of X-rays less than that of the wavelengths of UV, and the wavelengths of UV is less than that of the wavelengths of IR, and the wavelengths of IR is less than that of the wavelengths of microwave, and the wavelengths of microwave is less than that of the wavelengths of radio wave. So electromagnetic spectrum is the spectrum which arranges electromagnetic radiation from the lowest wavelengths to the highest, or from the highest energy to the lowest energy, or from the highest frequency to the lowest frequency, which means the energy of gamma rays is greater than that of the energy of X-rays. The energy of X-ray is greater than that of the energy of UV. The energy of UV is greater than that of the energy of IR. The energy of IR is greater than that of the energy of microwave. The energy of microwave is greater than that of the energy of radio wave. The same is true for the frequency. The frequency of gamma ray is greater than that of the frequency of X-rays. The frequency of X-ray is greater than that of the frequency of UV. The frequency of UV is greater than that of the frequency of IR. The frequency of IR is greater than that of the frequency of microwave, and the frequency of microwave is greater than that of the frequency of radio wave. That is why electromagnetic spectrum arranges all electromagnetic radiation from the lowest to the highest wavelengths, as well as arranges all electromagnetic radiation from the highest energy to the lowest energy. Again, the third one arranges all electromagnetic radiation from the highest frequency to the lowest frequency. This is the principle of electromagnetic spectrum. ሌላ example 1.3 Ethiopian National Radio Addis Ababa station broadcasts its AM signal at frequency of 2400 and 2400 kilohertz. What the wavelengths of the radio wave expressed in meters? ይህ ማለት 1 2 2.4 times kilo 2.4 times 10 the power of 3 ማለት ነው። ኪሎ ማለትም times 10 the power of 3 ማለት ነው። 2.4 times 10 the power of 6 hertz ይሆናል። ይሄኛው 2.4 times 10 the power of 6 hertz ይሆናል or 1/2 ይሆናል። so ቅድም ምን ብለናል? C is equivalent with lambda times v. so lambda ለማግኘት ምንድነው የምንለው over v. so lambda is equivalent with speed of light over frequency ነው የሚሆነው ማለት ነው። so finally 125 ሜትር ይሆናል። next exercise 1.4 the most intense radiation which is emitted by the earth as a wavelength of this one a lambda ነው። lambda what አሁን v ነው ካልኩሌት የምናደርገው v ካልኩሌት እናደርጋለን። ቀላል ነው። አሁን ምንድነው ቅድም እቺን ፎርሙላ ነው የምንጠቀመው c is equivalent with v times lambda ብለናል። so over lambda frequency speed of light over lambda ይሆናል። frequency is speed of light over lambda ይሆናል። ይሄ ማይክሮ ማለት 10 times 10 the power of -6 ሜትር ይሆናል። ቀላል። the same is true for question number 2 Addis Ababa Fana FM radio station broadcasts electromagnetic radiation at frequency of 98.1 megahertz. What the wavelength of the radio wave? The same is true. Speed of light lambda times v. What is the wavelength of the radio wave over v nominal over v nominal? Lambda is equivalent with is over v ይሆናል። s አለን v ይሄ አለን። Thank you very much. Next we will start from quantum theory and photon. Thank you very much.